So now our plan is to integrate using logarithmic or exponential functions. Really, we are going to do the integral of the exponential function of base A. So think back to when we just talked about the derivative of the exponential function of base A, that's a to the x times the natural log of a. Since that's true, we know that the integral of a to the x with respect to x is, well, itself, because itself is in the derivative, but instead of multiplying by the constant natural log of a, I'm doing the opposite. What's the opposite of multiply? Divide. Divide by the constant natural log of a, and of course add plus c. So again, here is our formula. Know how to go backwards. Memorize this. Let's practice. So I see I have an exponential function. Base is not e, base is 2. So I think to myself, it's like the easiest where it's itself, but I'm dividing by the extra constant of natural log of the base. Don't forget about plus c. Here again, I have a problem where I'm integrating 2 to the 3x, and I may think to myself, I need to use substitution because the exponent is more than just x. But remember, we can simplify exponential functions. Think of this as 2 cubed to the x, and therefore we get 8 to the x. Now it's easier to integrate. 8 to the x itself divided by natural log of 8, and then of course plus c. There's my derivative. But sometimes it's going to be a little bit more complicated. So what happens then? Well, if the exponent is more than just x, just like in our exponential functions of base e, call the exponent u. Off to the side, let's write down u and du dx. Solving for dx, we see du over 3. So taking out dx, putting in du over 3, let's rewrite our integral. Integral of 2 to the u, du over 3, well, I don't need over 3, I can pull out the 1/3. So really I have 1/3 integral of 2 to the u du. 1/3 is just a constant multiple. Do my antiderivative of 2 to the u. 2 to the u over natural log of 2. Don't forget plus c, and don't forget to plug back what u equals. Let's write our final answer. 1/3, 2 to the 3x minus 5 over natural log of 2 plus c. But does this have to be our final answer? No way. We can simplify this. How? The 3 multiplied to the natural log? Make it the exponent right there. So let's write an even better answer. 2 to the 3x minus 5 over natural log of 8, and then plus c. There's a nice clean answer for you. Now, what do we do when we see a log in our integral? Do we know integrals of logs? No, we don't. So I don't want the log to be there. I don't want this log there. So what do I do when there's something there and I don't want it to be there? That's what u substitution is for. Call it u. So I'm going to say let u equal the log of x. That means I need to find du dx. So this is, remember, base 10. So this is 1 over x times 1 over natural log of 10. Let's solve for dx. X natural log of 10 times du. Right? Cross multiply. Du times all this, dx times all that. There you go. So dx comes out, and x times natural log of 10 du goes in its place. Let's rewrite what our integral says. Integral of, this came out, but the squared is still there. So u squared over x times all this, x natural log of 10 du. Well, this is looking promising because my x's cancel out. What am I left with? Integral of u squared. Natural log of 10 is just a constant multiple, so really I can write it on the outside of my integral. Let me save some room for that. Natural log of 10 on the outside of my integral, then u squared, then du. Natural log of 10, there's no letters in that, no variables in that, so it can come out, it's out. Do the antiderivative of u squared, u cubed over 3 plus c. Don't forget to plug in what u is. Remember, one of the most important steps, plugging this back in where the u is. Let's go ahead and do that. Natural log of 10, u is log 10. Oops, sorry, log x, that's base 10. It is cubed, it is over 3, and it is plus c. Looks good.